Hello and welcome. In this series of videos, we will talk about the rotor blades of wind turbines. And this series of videos I will do and explain together with my colleague Hannah Neumann. In total, we will talk about the following. We will discuss whether the movement of the rotor blades is due to the air resistance or due to lift forces. Then we will talk about the difference between aircrafts and wind turbines. We will talk about the aerodynamic dimensioning of a rotor blade. And by that we will learn to know phrases like the pitch angle or the rotor depth. Then we will also discuss why do nowadays wind turbines have more or less always 3 rotor blades and not only 1 or a lot of rotor blades. And then we will talk about the structural dimensioning of rotor blades, and amongst that we will discuss air and mass forces at the rotor and the materials we use for rotor blades. What are the aims of rotor blade dimensioning, Hannah?
Yeah, there are several aims of the rotor blade dimensioning. First of all, we want to reach a maximum power drain from the wind. And that is why we have to carry out an aerodynamic optimization of the rotor. Secondly, the rotor weight should be as low as possible, and therefore we have to carry out an optimization of the rotor stability. So in total, we want to minimize the material usage and thus the production costs, but at the same time we want to keep the aerodynamic properties.
When I have a look to those rotor blades at wind turbines, they have such a strange form and shape. I cannot imagine that we can do that just in a single step calculation.
No, you cannot do this, but you can use the blade element theory. The blade element theory is a model of fluid mechanics, and therefore the rotor blade is divided into elements of the thickness r, dr. You can see these blade elements in the picture on the right side at the lower rotor blade.
And then we divide the complete area of the rotor blade in small area of circular rings, and each of them has then the area dAr equal to 2p times the radius of that ring times dr, and that is the thickness of those single rings.
Yes, that is true. And additionally, the blade elements rotate in the distance r from the rotor axis. You can also see the distance r in the picture on the right side. And the flow distribution and the air forces are then determined for each single blade element. We can do this when assuming that the air forces of the blade elements do not affect each other. So from that, we get some dimensioning targets at the nominal operation point of such a rotor blade. We want to reach equal flow distribution at each of these blade elements, and we want to reach a maximum power drain at each of the single blade elements.
And before we go into detail how we calculate the dimensioning of those rotor blades, in the next video we will have a look why airplanes are able to fly. And that is more or less the same reason why the rotor blades of wind turbines are rotating. Thank you very much.